Hey, morning. The first message didn't pop up on YouTube. I heard the noise, but it didn't show up on stream, so I just opened up the stream, and it's they seem to be showing now. Yeah, I've got a 250 gram. That's how I can measure my coffee intake now. I'm grinding my own beans in a Sage machine, and I'm putting 250 grams of beans in basically at a time in the hopper. So I know I've got through 250 grams of coffee in 2 days, I think. 2.5 days maybe. And ironically, I've been up since about 2:30. Nothing to do with the new coffee like, but so yeah, nice and early. Let me just pull up the Twitch to make sure that's streaming as well. Yeah, so Twitch is active as well. I'll just give it 5 minutes for most people to jump on who are coming on this morning, then we'll get started. Where's everybody from this morning in terms of location, so we can start getting an idea of, you know, what section of the world watch in the morning versus the afternoon. Hey, welcome in, NanoFix. Just giving it a few minutes for everybody to join in, so they don't miss out. And it's definitely winter now here. Heating's on everywhere. So, well, the heating off right up until like 2 days ago for a good 6 months, I'd say. And now the electric bill is going through the roof. Oh, nice and early. You're up as early as me then. Or have you stayed up? Have you not gone bed yet? Is it a late one or an early one? Yeah, quite a few. US and Canada, I'd say, is the main time for this this early morning one. But again, it's obviously late for you guys, I presume. Those streams are okay. We actually don't have either. We don't have anyone in Twitch, or it's not working. There's only me showing. Let me just put a test message on Twitch as well. We probably just don't have people in Twitch on at the minute. Yes, that's working. So let's close the streams. We should be good. Right, so we'll get started anyway. So the goal of this video is I kind of want to go through all the equipment that we use. Like, well, I've got a hell of a lot of equipment, but the majority of equipment on my desk. So a lot of you have asked about what we use, and you see what I use, but there's a lot more equipment than you've seen on stream. I've got, you know, things under my tub, things in cupboards behind me, things in the garage. So we'll go through. We won't go into so much, you know, specifics. We're going to do the multimeter in the next stream very specifically, but we'll go over what each tool is, why you might need it, and maybe what brands I'd recommend, or if you've got a budget, you can let me know, you know, which ones you'd recommend, and then we could also make maybe a list that we publish somewhere of recommended tools and prices and stuff. Usually go to sleep about 1. Yeah, I used to be early. Well, I've always woke up early, like 6 in the morning, and then I'd usually go bed fairly early, like go up 9, half 9, watch an hour to 2 hours of TV, fall asleep about 11ish. Whereas at the minute I'm probably going up at 10, falling asleep at midnight, and then I'm up at anywhere from literally between 3 and 5 at the minute. So I've definitely gained more hours, and yet it's darker as well. I normally just wake up with the daylight, and at the minute I just wake up all the time nice and early. Fluke's good and overpriced. I wouldn't really know because to be honest, multimeter wise, I've used Fluke, I've used loads of knockoffs, I've used Fleur or Fleer. Nothing's even come close to a Fluke. So I've used these in automotive, I've used them in mains voltage, I've used them in electronics. I could easily go through why there's so many things in this that are better than every other, one I've used of even higher price. But mainly the simple speed of reaction and reliability, like the instant latch features, the voltage speed, the voltage recognition. And you can get these. I think this is a cheap one I've got on here. This is like a £70 one. So I'd absolutely recommend these. So yeah, basically one of the first things that you'll need for any real repair, I'd say if you're going to buy one tool and you're starting off in diagnostics, it's got to be a multimeter for obvious reasons. This is, and again, most people might know this, but we're going to go over all the basics to make sure anyone that's watching that, hasn't done any repairs and wants to learn, then I'm still going to cover everything. So multimeter looks similar to this. The cheap ones I wouldn't recommend in these because what you'll find, I'd probably have to get an image up on screen. Oh yeah, they'd be fake flukes. They are quite good at finding people that clone them and taking them down, but I'd just go straight to Farnell. I think in the US, what's your main electronics? Like DigiKey is for like components, but as in devices, I can't think of the name. I used to buy them all over there. I used to have a business over there, and used to go and you can literally go and drive and pick them up out of main place. I can't even think of the name of them. But I'd go to an actual brick and mortar store and pick one up, or go to a reputable online like Newark. I think it's Newark, which is Farnell in the UK. So I think Newark Electronics, that might be it. Yeah, I think I might still be on an English one, but no, I think that's it. I think is Newark popular in the US? But yeah, if not, DigiKey probably sell them as well. But I know like for components, I tend to go to like Farnell or Mouser. But this is a really good fluke that's cheap. I'm sure these are like 70 odd pounds, and this is good enough for most of what you'd need. No, this isn't the, well, is it cheap? 120 I can see it on Farnell. Yeah, but either way, I would spend the money investing in this, because the cheap ones, that's what I was going to pull up. I can't, every time I see anyone using a cheap one, I'm like, how do you put up with that? It hasn't even got a display. You have now I'm trying to find a cheap one with an image to show you. I can't even find it, but you guys will know it's there we go. This is the classic YouTuber super cheap horrible multimeter. Let me pull this thing up. This is what I never want to see anybody using, these things where you've got your little, monochromatic 3-digit display. Why are these so popular? They're as good as useless. You might as well lick your finger, touch the circuit, and tell me how much voltage is on. So don't use them. Just invest in one of these, basically, for your first endeavour into electronics, if you want to do it seriously. Otherwise, there's not much point. If you can't trust your measurements, then you're in trouble. And then what we will do, we'll cover this actual, how to use a multimeter and that in a separate video. This is just to go over the tools as a whole first and why you'd need them. So multimeter is used for obviously measuring your AC voltage, your DC voltage. So AC is alternating, as in usually mains voltage, or transformers. So in things like game gears, where you've got transformers like here, and it makes where it starts is it'll start with a DC voltage at like 5 volts, which is flat. Then it'll make a self-oscillating circuit through like resistors and capacitors normally, where a capacitor will charge up, cause current to flow through a transformer. That will lower the voltage. That will turn a transistor on and off, and it basically self-oscillates, causing the voltage to go high, low, high, low, high, low. That passes through a transformer, which is coils of wire overlapping to change the voltage ratio. So you can go from a 5 volt to thousands of volts if you like. That's about the only time you'd see AC, really. Like as in AC voltage you want to measure on here, a static sine wave, constant fixed frequency AC. You wouldn't use this to measure, like data signals. It's purely for mains powered AC. So short of a Game Gear or an Atari Lynx with a transformer, you'll rarely use AC and electronics. It's more for electrical, like mains electrical. So we'd usually be on DC, the flat line. And then you've got millivolts on this one, which you don't always need, but that's if you want to try and measure accurate millivolts. So, you know, lower than 100, like, well, lower than 1 volt, technically. Anything lower than 1 volt will start measuring millivolts. You've got ohms, which is resistance, so resistors, obviously, touching between them. Continuity for checking for broken traces, things like that. There's more features on them, but that's your main purpose of a multimeter. So if you want to do any kind of diagnostics, you really need to start with one of these. And like I say, we'll go through this in more detail in, I think it's the next stream. So that's what we'll cover. You know, we'll cover them in more detail as well, different versions and every mode and how you use them and things. There's a store called Granger, is that sells them in the US. I haven't heard of Granger. Simpson and Flukes. Yeah, I'm gonna have to try and remember, because none of them are ringing a bell. It was just not necessarily, might not have been a hardware dedicated store, but it's like in the UK, you want, say, something like a chainsaw, you've got to go online and order one, or go a very specialist store. In the US, you just go grocery shopping and buy a chainsaw off the shelf. It's like crazy, the differences of things you can just go out and buy, and it's like normal compared to over here. So like, you can't go out anywhere over the UK and just go and buy a multimeter. Nowhere I know of. You'd have to go a specialist shop somewhere, and I don't even know if there's a single one in the UK. I used to drive to... where was it I used to drive to? I think it was Farnell. I used to physically drive to Farnell in the UK to pick up multimeters and things. But other than that, no, it's not. You can't just go and grab stuff in the UK, I find. Right, so short of a multimeter, next up, what I'd probably say you'd need, obviously, is going to be soldering irons. So I've covered these quite a bit in that throughout the videos. You've seen me use multiple. I've got a decent one here. So this is the first real decent one I could afford when I was doing it years ago. This is a Wala. I think it's a WD1. They're quite cheap now. You can get these for like £200. So if you wanted a used Wala, I'd probably recommend these. These are amazing. It's been used that much that you can't really see the writing on the iron, but I think it's a WMRP or something, but I can get all the details on when we come to cover these. These just have nice removable tips, so even when they're on, you just remove them, and it's literally got a 3-point headphone jack connector. So really nice and easy to change tips while you're working. And it's got something called active tip technology, so it measures the temperature in the probe itself in this actual, you know, iron, whereas others measure the temperature of a stalk here or into the body or how much current. The Walas measure the actual tip temperature, so it's way more accurate, and you do notice it. Which isn't being queued for multimeters. I didn't even know that, to be honest. Got one local and I've never really noticed that. For cheapness, if you wanted irons, there are some really good ones. I've used them. This make, funnily enough, actually it's gone off my desk. Oh no, there, the new hot air. This make, this Yeehaw, as I like to say, Yeehwa. If you search for C245 soldering irons, they're basically clones of the JBC. They are really good. Now, admittedly, they're not quite as good as like the Walas. Now I've plugged this back in, but they are incredibly good for the money. So the cheapest one I brought was £50. I brought recently, if you look back at the streams from just a week ago, maybe 2 weeks ago, the iron I'm using in that is a £50 iron, and it does the job. I could do all my job with that if I wanted. So I wouldn't overspend on an iron to begin with, because there's just no need. Spend your money on an expensive iron when you've got the money for one, just for the fact you can. And then you've got Hakko's, Walas, JBCs, they're your high-end makes. Hakko's probably the lowest end make. Walas the next make up, and JBC is the most expensive. Personally though, I don't think I've ever used a JBC that I can remember, all the clones I've used. But the Walas I've used loads of, and I still think the Wala is the best for, well, the best thing I've used so far, basically. Yeah, Yeehaw 982, that's the one. So again, we'll probably cover, well, we will cover, you know, soldering tutorials. when we get to it. But again, to give you an idea what you need one for, you need one to actually solder, pretty obviously. So if you wanted to, well, you do and you don't actually. If you wanted to work on this board, and we zoomed in a bit, and say you wanted to, it depends what work you're going to do. If you're going to repair things, I'd say you almost always will need an iron. But say for whatever reason your only job was to swap resistors out, you could just use a hot air and tweezers and take them on and off, but then you still can't apply fresh solder. So I don't think you're ever getting away with not really needing a soldering iron for soldering. But obviously a common task would be just something like this. Say you wanted to reflow or take a resistor off, and then the very next thing you need, as soon as you start soldering, you go, oh, this is good, right, how do I pick that up? As silly as it sounds, you need a set of tweezers. And even these are things that you can find good and bad of. So there's multiple sets of tweezers. I go through loads. What I look for, there's quite a few. So if I get, well, Zach uses the ones I used to use, and I no longer use them because I used to bend them all the time. So let me just grab one of Zach's pair as well. Well, two of. There's a good pair and in fact he's got my better pair. I need to buy some more of these. So I use this. They're all stainless steel, or they say they are. This one's a Mechanic KS11 probably, based on that. I use a tip that's, again, similar to my soldering iron, quite thick in a sense. It comes to a point, so you can see it like goes over to a point, but these are the ones we used to use, and I used to make these. So I say, obviously I didn't own these or make them out. I used my factory to make thousands of them, and we used to print our logo on, modify, when I used to do Xbox controllers and gaming and stuff. So we used to buy these and write modify on them. So I know these were good. These are like stainless steel, really fine tip, so much finer tip than that. And then obviously the goal is you can pick up things. I'm looking at the stream with a delay on instead of looking at the actual component. You can pick things up, but you see how I struggle with these now because I'm not used to them. The fine tip can misalign. So again, this is one thing that used to drive me nuts with these. Is if you look at the tip from the side, there's Zach's tweezers. Shall we fix them for him, because that's atrocious. That alignment is one of the reasons I stopped using these. So the only way to really fix these is to try and bend them back in. So I just get like cutters and twist like that. So kind of bend the arm up a little bit, and you watch I'll break his tweezers. Nearly. But the problem with these was they are too soft for me. So the fact you can manipulate them and bend them that easy, there we go, they're back into place. When they're in position, or almost now, I could keep going, but you get the idea. When they're in position, the better. You can grab now nice and easy without struggling. So turn it around, pick up. But I didn't like the fact that I was always bending these. I use my tweezers for loads of different things. I'll like, you know, pick chips up and grab under, and I'll test pins and probe things, and these just bend on me too easy. So I went to these, which are very strong. So even though they're fine enough to pick stuff up, you can still pick things up, and you've also got more surface area when you're picking up. I personally prefer these kind of fatter tweezers now. I just find them a lot more easy to grab things, and they don't, you almost never, I don't think I've actually broken a pair of these. I lost one, but I've never broken or bent a pair. And then in between them two, or maybe in between, is these are actually good. So these are still fine tip. So you have like tweezers like this. They're the 3, for example. Zach's at the top. The middle ones were mine, and Zach had them, I think. Nice little sharp pointies, and then mine are at the bottom. You can get all of these. They're all on AliExpress. This one is just a 2UUL 3D, it's called. These are good. Like I say, good in between the two. So you can still grab. These are a lot tougher than these as well. So these are probably now, I'd say, my least favourite, and yet they're Zach's favourite because we use them from the start. But these are, I'd say, go with these or these. So a Mechanic KS11, I think that is, or a 2UUL 3D. They're the two I'd recommend. You shouldn't need any other tweezers, really. I don't think I have. The only other thing I did was, if you ever want to probe things, you can see, here's my blue one. Snap them in half, just bend them and break them. And then you've got the tip there, and you can see this one snapped off. So then I've got another pair similar to this, done the same thing, snapped it in half, and then I bend the tip over. So I put like a little kink on the tip. I think this one's got more, there's 2 levels. This one's got like the sharpest bend, and I use that when I'm going onto circuit boards here and I want to push, when you see me like dragging and pushing pins like this. But somebody recommended a dental pick for that yesterday, so I've ordered one of them as well. Scratching the board, you can do, but again, with this, a lot less likely, because this tip isn't, no, it doesn't hurt, whereas these, they're like sharper. So, especially these are like needles. I've stabbed myself with these a few times. So, personally, these are my ones, but yeah, you'll need tweezers right after a soldering iron, I'd say. Also, a good thing for multimeters is spare probes and tips. So sometimes you want like fine pointy tips, which are when you want to probe certain areas on the board. So if you've got, say, this board, and we grabbed my multimeter probe, I've got fine tips on mine, of course. So my multimeter, you can see I've already got like fine tips on, needle points, but they come with fatter tips, so a lot larger by default. Oh, even that one's got it on. Every set of multimeters I've got has got the fine tips on already, but they come with really fat, yeah, I've got none around, really fat probe tips by default. I normally swap them for these kind of finer points, so that if you did want to probe certain areas and inject voltage or test things, you've got your finer tips. Let's put these back before I get told off for stealing tweezers. And we won't need that resistor because we're going to work on that yin board. And then pretty much in a similar fashion, once you start working, you will be able now to measure a circuit, realise that you need to fix something. You can now solder, so you've got a soldering iron, you've got your tweezers, and then you decide you want to do, say, a jumper wire to repair something. So the next thing you'll need is wire. There's various kinds. I wouldn't recommend starting with what I use, which is, in fact, I've got a fresh reel I can grab for you. That'll just have to deliver. I've already put away safely somewhere that I can't find. Literally didn't even put it in a box, just sitting on the shelf. This is the wire that I use, this enamelled wire. So it's called enamel wire, and it's like 0.2 millimeters thick. I use this all the time universally, unless it's something for repairing power traces that need power. And then for power traces, I just go thicker, and I go to silicon wire, which is quite thick. So you'll see me attaching this normally for like if I want to attach a ground for my oscilloscope probe or inject power, I'll use this soft silicon wire. Nothing specific about these. Use the thickness you're comfortable with. But if you're doing mods and running wires, then you can really use the enamel wire that I've got, which is nice and thin. Or what I used to use, and again, what Zach still uses but I don't now, is what's called Kynar wire. Well, that's the typical name, K-Y-N-A-R, Kynar wire. And this is in between the two. So this is like thin wire, but still single core and a plastic insulator, versus the enamel wire, which is enamel, obviously. So we have enamel wire here, nice and thin. You've got the power wire here, which is whatever thickness you really want it to be to handle power, but it's not good for modding. And then you've got, if I can unravel this, you've got this, which is a nice in-between, this Kynar wire. So I'd personally recommend you start with this. And this is 28 American wire gauge, I believe it is. 26 starts getting thicker, some people prefer that. 30 gets too thin really, so between 28 and 26 kind of wire is what I'd recommend you start with. Maybe grab yourself some, I don't know, speaker wire, so it comes in red and black and it's about this thick. That'll do you for your thicker wire. And if you want to get into like trace repairs and or more advanced mods, go with enamel coated wire. Tools for fixing GBA CPU with badly bent pins. I can go over pin repair. We can, if you chuck that, if you're in the Discord, chuck that message in the Discord as a recommended video. We'll do a video dedicated to fixing bent pins on CPUs because that is a good topic to cover. And we'll go in detail how I do it. It all depends on how far it's bent, how many pins are bent, the condition of the board underneath. Every single one of those things determines how I'd tackle the repair, and it'd be different for every case. So I could explain to you one way of repairing, but literally I'd repair a CPU differently based on all of them circumstances. So we'd really want to cover all of them in a video. I think like every scenario, a single bent pin, an entire side that's all bent and swiped, a pin that's broke off, a pin that's bent but the trace is missing, all kinds of stuff like that, that every single one would be a different technique. Yeah, you can also, the only thing with opening up like old equipment for wire is it's normally oxidized quite badly, so you can struggle to get solder to stick, or the insulation might already be breaking down, so you might start getting you know, conductivity where you didn't think you would, is the only other potential there. Yeah, so say you then want to come to add a wire to this board, say bridge this resistor. The next thing you're going to want to do that is the wire to do it, but also some kind of cutters. So again, cutters are people's choices. These are the ones I use for most stuff. So these are, well, I don't know, these aren't the original now. Oh, what was the name of these originals? Oh, it is, yeah, CK. I was going to say they're not the originals. CK Electronica, these are the originals. These are good. There's clones of them everywhere. But if you get the originals, these are by far the best. They hold the tip the longest. But a word of caution, don't go cutting heavy stuff with this. So cut your wires. Don't attempt to cut metal. Don't attempt to trim corners as like fiberglass boards. Treat them with care and treat them like wire strippers and cutters. Otherwise you get dents in them, like I'm sure I could easily show you that I bet mine have got dents in. I mean, I do try to look after them, but I'm sure I've probably used them once or twice where I shouldn't. I don't know, they're pretty clean. You can see where I've been cutting wire, but this is the part I mean here, where I close. See, yeah, mine are pretty perfect. But you'll get, if you cut something too thick, this will just indent the cutting head, and then you'll have a hole in here. So when you try to cut wire or strip wire, it doesn't cut where you're cutting basically. So just use these with care. T3887, and you can see cutting anything for soft copper less than 1.6 mil. It even tells you like that's what they're designed for. Once you get to heavier cutting, you obviously want to go to heavier tools, and then at that point I've got two things basically. I've got a really crazy overpowered, well not overpowered, it's used for what it's used for, big set of like pliers. Don't know where I got these from. I think it was just strangely enough, a TikTok advert, but big heavy duty grips and cuts. So I cut anything thicker with this that, you know, it just requires heavy cutting. And then if you need to cut metal, I've got actual metal snips, or tin snippers I think they're normally called in the US, or tin snips. But basically for cutting metal cages like SNESes, you want to get dedicated metal cutters, because if you cut with, even if these things can cut through metal, they're not serrated edges, the clean blade. So you'll cut through things and leave a razor sharp edge on the metal that you'll then slice your hand up with. If you use tin snips, they actually have serrated edges, so it softens. They'll still be sharp, but the edges are a lot softer, basically. Yeah, like something new like a PC. Yeah, a dead PC power supply is a good example of grabbing some free wire. Also, I guess anything that isn't really old you can grab wire out of. A lot of consumer electronics die these days, not because of age of like the wires and things. It's literally just the ICs die, the batteries die. They're just not designed to last anymore. So we've got the wire, you've got your cutters, you've got your soldering iron now, you've got your multimeter to measure. I'd say probably, what would we have next maybe? I don't know whether you'd go to hot air next. No, you'd go to a bench power supply next, I think. So if you had an issue on this and you wanted to, say, diagnose it, a really useful diagnostics is power draw. Being able to, plus if you don't have a power supply for it, you need to be able to inject voltage. A poor man's solution is getting a USB cable, cutting the end off, picking the 2 wires that give you 5 volts, using your multimeter to figure out which, and then have 2 flying leads. And I think they even have a wire, just like that, sitting here. So this is, this is used the opposite way around. So I use this to inject voltage from a bench power supply into a USB source. Whereas what I'm talking about is the other way around, where we want to plug this into a USB source and have the wires out. So it would look like this, but if you're going to do it on USB, you can't just use a USB-C end because they have to negotiate power. You'd have to use a standard USB-A end. So you'd have to get one of these cables, cut the other end off, and then expose the wires like this. And now you could solder this onto a board, plug this into a USB plug, and get your 5 volts into your system. So that's like a cheap way of doing voltage injection. But the proper way is to use a bench power supply. And then I guess the bench power supply is the thing I struggle to show you, but I don't know why, because I forgot this camera here. I can just push. Literally, it's on a floating arm, so I should be able to push that camera around, or to be honest, untwizzle it a bit. Can we do that? Fully twizzle. And then can we now point down to the multimeter? I can never get in focus for you. I've got a grip arm on there. Let me remove him a minute. Or move him out the way. I need a floating camera, like we said, for being able to show off what I want behind my desk. Almost. What have we got on the way there? Is it just the bar again itself? Yeah, I think we have to keep going over. Oh, it's the actual camera itself. Yeah, the base of this camera. I might take this camera off then. I can't take my face cam off because he's stuck on. You can see there. He's literally, I've stuck him on my microscope. I can. Yeah, that's probably why this was failing, to be honest. When I look at this, the HDMI cable's got a massive bend in it. Oh, that's because I've twisted the camera around. I was going to say that's might be why it was failing. Yeah, I can't get that out of there. Have I got another bench? I've got Zach's bench power supply. Do I maybe nick that a minute? No, I don't like that one. I want to show you mine. Let me then unscrew this and I'll hover him. It's not going to be the best way, but I'm only showing you the multimeter so you can see what it is. Actually, can I do this? Will this self-level if I twist it around like that? This is either a really good idea or really bad, because I'm either going to break the HDMI cable and then we've got no camera, or this will work. Oh, that's sideways, that's trippy. Look at that, there we go, you can finally see the multimeter. So yeah, the bench power. So you're now looking at the bench power sideways, that's how you're looking at it for today. So this is one that stacks, so you can see down here, we've got this Rigel DP832A, is that? Yeah, DP832A, that's really hard to read sideways. Above it is a signal generator, waveform generator. You won't need that for a long while. Above that's an electronic load, so this thing up here we can inject load. You can like load down a circuit to test circuits, and above that's the multimeter I use on stream. So the main thing is at the bottom. I'll go over here to do it. This is when you want to inject power into circuits. So for this one I've just got a on switch here. I've got 3 channels, so normally you'll get 1. So this is the output of 1, this is the output of another, this is the output of another. And I've got 3 channels here, 1, 2 and 3. I can see my hands pretty much in the way of all of that. So you've got channel 1 here on, channel 2 here, channel 3. So that'll output this. So these 2 pins down here, these two wires here are this output channel here. So if I turn that on, I've now got 9 volts coming out of the channel. I can adjust the voltage, say like 5 volt, and I can limit the current, which is important. So I could do say 1 amp. So now it's got a limit down here of 1 amp on the 5 volt rail, and that means I can, if I turn on my fancy overlay multimeter, so we can see. Why has this camera stopped tracking? Track me. Apparently not. Track me. There we go. Weird talking to a camera. Right, so that's turned on down there. I can now open my multimeter software and then turn on. And now I could take the probes of, you can probably see them both over here actually. I've got these probes here, the red and green, are here. And if I connect them to the multimeter, which is just above it here, so I can grab like the black from the multimeter probe, connect it to the black of the power supply that's turned on, and then we have now the that's the output, the 5 volts from the bench power. This is the multimeter probe. So if I connect them together, you can see that's then showing us the 5 volts on screen. And if then we change the voltage, we can use left and right on here as well, and there's an arrow under here normally. If you tap volts, I believe, is this one I can do it on? Can't see looking sideways, but you can use this dial anyway to adjust as well. Adjust voltages up and down. Or you can just type in new voltages like 3 volt, and then you can see it update on screen there for you. So bench power supply, we'll go through bench power supplies specifically and in detail, because like most equipment, everything's easy to show off. Now I've got to try and get this thing back into some kind of position it was in. This will be fun, because this took me ages to get this position just right. Let's see if that's roughly somewhere. Yeah, the bench powers, you can do so much with them, and there's so many things to cover and things to look out for. I think that was about there, down. Yeah, that wasn't too bad, that's about there. Yeah, so bench powers, I'd say you need them sooner than you think, and a lot of people don't have them. And it's one of the downsides. If they're trying to fix stuff, then they never seem to have a bench power supply. They don't see the importance of it, basically. And what I would use that for is, like I say, if I wanted to diagnose this, if you've only got a multimeter, you can only really check for the voltage coming in, resistance. You can check for current, but it's a bit harder to do, so I'll show you how to do that in the next stream. And then short of that, the next thing I'd say is, right, we want to either look for heat with a thermal camera, or we want to more accurately use a bench power to see what the entire system's pulling, because that tells us so many things instantly. One, if it's 0 amps, there's something majorly wrong, you've got no power going into the system. 2 is if you get power and it's way above what it should be, either a dead short, you know, there's literally, like it's pulling 3 amps and smoking, you know, there's a dead short somewhere. Third, you can have, say, a game gear that's expected to pull 120 milliamps or something, and it's pulling 400, so it's not a dead short, but it's way more power. That immediately tells us it's probably a single IC that's dead and not a short. So for the sake of getting a bench power, hooking up 2 power rails and looking at the power draw, I could tell you on this game gear whether it's one of 4 things in less than half a second of where to then focus your, you know, search on, basically. It gives you an immediate indication of the fault. I don't really see anybody else using bench power supplies in that way, and I used it on RetroSix.wiki for the Nintendo Switch repairs when they first come out. So if we just took a quick look at that, you can see how useful bench power supplies are when you use them correctly, or for the purpose I use them for at least. If I pull this up and we go to where are we? Is it Switch or Nintendo Switch? Nintendo Switch. You've got dead shorts, so you can see here all the rails I specify literally what current every single individual rail should pull. So if you wanted to diagnose a Nintendo Switch, you can inject the specific 1 volt into every point on this board, see if you match these currents, and if you don't, you know you've got a fault on that exact area of the switch. I also did first stage boot. So again, you can bypass all of the circuit, you can bypass the charge circuit, which turns out to be faulty a lot of the time. I'll show you this exact multimeter, or this exact bench power rather, how to inject it, what to do, where to attach wires, and then you basically, through all this, you're looking for, you know, how much current has been pulled. So you should expect 0.01 amp to 0.005 amp. And then its next stages you want to turn on with tweezers, and you're expecting 193 milliamp. And this is an exact thing as well on the switch. You can tell within 10 or 20 milliamps. If this thing boots to 190 and stalls, then it can be like the max chip, or it can be the M92. If you get to second stage boot, you see the 192 jump up to 2 to 300 or 4 to 600 if the backlight's on. There's loads of really useful diagnostics using a bench power, so I'd say that would be next up on this list basically. I'm an embedded developer or electronics. Well, I'm not trained in anything. I'm all self-taught, so I wouldn't class myself as any one of them specifically. But what I do is obviously repair, solder, build boards up. I make boards, so I've made this. I make full electronics, so this is like the entire screen I've made with FPGAs. I do the software side, so I've done MCUs, I've done RP2040s, done power circuit design. I'm a software developer, so I run a software business. So the multimeter stuff you just saw on screen. This thing here, I've made that. I wrote that this weekend, and that's on Angel 6's YouTube. So yeah, I'm a bit of everything really, but no education whatsoever. Right, so we've got the bench power supply. Well, you saw, I'm not going to swing the camera all the way around again, but you saw at the top above that bench power, you saw another brick. That's called a frequency generator. And what that does is generate AC waves, but more specifically, usually things like sweeping signals going from 1 kilohertz up to a megahertz, or random noise, or things like that. That's mainly used for either testing audio, testing equipment. I usually use it to inject potentially clocks into systems. So instead of having the Game Gear's clock, well, you can't do it in this case because this is not an oscillator, it's a crystal. But in certain systems where you have clocks, you can completely bypass it and inject clocks, things like that. Pretty rare use case. I don't think you guys would need it or use it. Above that, there was an electronic load. That's very useful for, say, when I made this here. So this is a Dreamcast Clean Power. This is a dev one. This is one that obviously I was testing and building a new design. Once I've built this and designed it, it's no good to just measure, oh, we get 3.3 volts and 5 and 12, because when you put it in a Dreamcast, this is going to load down these rails with like 2-3 amps of current draw. And I want to monitor that and test this product before it goes into the system. So I need to simulate a Dreamcast by loading down these rails and pulling, if you will, pulling like a few amps off the 3 volt rail and making sure it still stabilizes, and then using an oscilloscope to probe that the 3.3 volt rail is nice and stable. So the things you can do that with, one, you can just use big fat resistors, like giant, they're called, I think they're just called power resistors, and they have a big metal cage outside, and it tries to keep the resistor cool, and it's just a big shunt. You just attach it, use Ohm's law to figure out how much it's going to pull. Again, a very crude way, but it can like forcefully load down the rail. You could even use things like just donor consoles if you wanted to risk them and load them down that way, but if you're getting serious into design and testing, you really need an electronic load to say, this is designed to handle up to 3 amps, so I want to put in half an amp and then go up to an amp and then 2 and then 3, and I want to monitor thermals and regulation using an oscilloscope. You need an electronic load for that, but you can think of it like basically an adjustable resistor that can weigh down circuits with current. That's what they're used for. Again, not so much a mainstream device. I'd say you only need one of them if you're building hardware. The only other time I'd say it's useful if you did own one would be to test, say, like if you've got a Game Gear power supply that you're plugging into this and the Game Gear won't boot. Like, say, this for example, one of our power cores. So you're plugging this into the Game Gear, turning on. I don't even know the state of this Game Gear, to be honest. Let's give it a quick turn on. See what's happening. See, so you can hear popping and cracking and burning there. No surprise, because it's a funny plain screen, but let's see if we get some... Oh yeah, I can smell. So you don't need any tools. I've used a USB, and I can smell burn. So this would be a good use case for the next thing, which would be a thermal camera. But yeah, if you had a electronic load now, and say this just didn't turn on, or it turned on and powered off, and you wanted to prove, is it this power supply, you could cut the wires or solder wires onto here and load down this power supply with, say, 1 amp, which is more than this should pull, and see if this still maintains 5 volts. Short of that though, like I say, an electronic load is a rarer use case. So I guess the next, we can put all that together as well, and use what we know. So let's say we now have the multimeter, the soldering iron, the wire, the cutters, the tweezers, a bench power supply, and we're going to introduce now a thermal, and we're going to try and diagnose this. This is not scripted at all. I just literally was about to work on this and transfer the ASIC over after this video. But considering this like smells of smoke as soon as I turn it on, it's a perfect example of trying to use a thermal. So for thermal cameras, pretty high up on the recommended list of things to buy. You can use things like IPA, which is cheaper, which you'll also need to clean your board. So when you're working, get some IPA. That's another thing you need. You would say we're trying to find this source of potential heat. You don't want to go touching around this board because the Game Gear has mains voltage on, but you could cover it in IPA. So before we use the thermal, let's just see if covering it in IPA exposes anything obvious. And what we're looking for is rapid evaporation of IPA. So turn on. Nothing. Oh, there you go. Smoke. So see how there's clearly smoke, but we don't know where it is, and the IPA hasn't evaporated. So we'd have to, wow, that is full on electrical burn. Let's turn on again this side and let's maybe spray. You can see how difficult it is to potentially identify the source of heat, and this could be a lot less obvious as well. So turn on. Oh, you can hear the sizzle, and yet see, I still can't find the source of the smoke. You just know it's down there somewhere. So instead of using that, you can get a thermal camera, and then we know it's coming down somewhere down here now. That's kind of semi-obvious for us. So you can see already without me turning it back on and off. Well, I'll tell you what, I'm going to plug this into the PC because this does have... actually, let me just go to this view instead, it's probably easier. I can plug this into the PC so it overlays, but I haven't set it up yet actually. So we know it's coming from under here, like down under this cartridge connector. So we kind of want to hover that up, and that's, well, I say it's down there. We've seen smoke down there, so I'm pretty confident it is. In fact, this is probably the perfect use case for this thing. Grab that board and lower that down, like that maybe. And I've got my little arm that holds it up, so then I can now free arm this, and we are, you can see how the resolution isn't that good on this. So what I tend to do is use my finger, and I'm pointing where I want the camera to point at, and then looking, and I know now I've got my bearings, we're looking under there. So if I now turn on, let's see what is happening. Oh, there you go. Shocker, funny plain screen. So then the way I identify where it is use tweezers, sometimes dipped in IPA that are cold. Go around, point with your tweezers, and now you can see there's my tweezers. See that like flappy tweezer there? So if I turn back on for a minute, because you're going to start smoking, get him back nice and hot, move the tweezers in while it's still warm, and then you can see I'm trying to get tweezers over. So that's now over the hot thing. And if we move away, I'm on this inductor. So that's with this thermal. You can get better thermals if you really want to see where the heat's coming from. This is the best thermal for the money by far. Let me move this up out of the way a minute. But you can see how useful a thermal camera is for specifically things like that. So that was genuinely unscripted, but as a perfect example of a thermal. But this is definitely the best thermal you can get for your money. And this thing is a Fleur ETS 320. And this thing will show you exactly where the problem is, like without any shadow of a doubt, without having to figure out where you are on the board. This is going to show you. So let's power him up. And we know the component now, but even if we didn't, let's presume we didn't, we put this under. You can see straight away if we move this up and down, I don't know which way we'd have to go, probably up. Look how much more accurate that is. So you can literally see the board. There's no guessing what's what. You can actually see, you know, there's the big copper pad. There's the ASIC. You can actually see the thing on thermal because it's that accurate. And when you put it in focus, it's even more accurate. So with that known, if I turn this on, we'll not only see the exact component that's hot, you'll see the exact trace where it's going to and coming from. So there you go. That's the exact chip. And then you can get your tweezers on that, for example. And as it cools down, you'll see. So you can see your tweezers coming in. You can touch the exact location. And you can confirm it's actually not the one we thought it was. Now we've got this one. It's the component next to the inductor. So you see how with the other one we presumed it was the inductor. It's actually the transistor next to it. And that's the benefit of having a more accurate thermal. So the problem with this board is this transistor here. And this is apparently a power supply, so it just looks like it's a probably a boost buck regulator. Might be a backlight regulator. Either way, I'm going to just cut that chip off because why not? He's gone. So now let's see if we clear. I should have just left that turned on. Let's see if we've cleared the heat. And this is where, if you use a bench power supply, like now we've cut that off, we're curious, have we fixed the problem? You know, is that problem gone now? How are you going to find out? So the way I'd find out if we fixed that problem is I'd power it from bench and monitor how much current was being pulled. Looking for the heat isn't necessarily going to tell us if we fixed it. So if we now turn on, you can see there's the no smoke. So nothing's getting hot now. We're turned on and running, and is the console now booting as well? No, so the console doesn't boot because this thing's probably fried other parts of it, but that's got rid of that short now, so there's no heat turned on. But if I was curious to diagnose further, that's where I'd then start getting the bench power supply out now to observe current draw, because we know it's had some form of issue with current and obviously being overloaded. So that's most of the major equipment. Let's go through what we have. We have the thermal camera, bench power, USB tweezers, cleaners, soldering iron. Hot air station is the one where I said it's really, you need a hot air station once you start taking off chips like this, so surface mount chips. You don't need them for resistors and caps because the 2-pin chips you can use a soldering iron, as you saw me use. But as soon as you start getting into large components, you really need a hot air station. You can go down the route of putting like these circuit boards on a hot plate, like a food hot plate, and setting them on and waiting ages and then lifting them off. Don't bother, just get a hot air station at that point. And then you can remove all the chips. I use hot air tons, but it all depends on where you're at. If you're working on Game Boys, for example, you're probably not going to need a hot air station because the only thing on there that's going to need it is the CPU or the RAM, and most people that work on Game Boys don't diagnose that far. They just buy another Game Boy, basically. But if you're going to do anything surface mount, you definitely want hot air. So that would be probably, I'd probably get a hot air station. Well, again, depends on where you're going with your workflow, but I'd say I'd get probably the hot air station before things like thermal, just because I think you'd end up using that more than you would a thermal. There's other ways of detecting shorts than a thermal camera. Obviously not as ideal, but there's cheap ways of doing it. So I'd probably invest in a hot air station before you do a thermal camera. And then obviously for safety, you want a fume extractor. So this is a good one. Again, 2 UUL. Again, quite a few things from them that are decent at the minute. This you just turn on, and then when you're soldering, you're not going to be breathing all these fumes in like I've done for way too long. So if you melt that now, you can see all your solder fumes get passed through this filter and blown out the back. If you're doing it a lot, like I am, I should really invest, and I'm probably going to, in another Walla proper fume extractor. I had one, I just never used it because it was too much of a faff to set up and turn on and things, but health and safety wise, I really should use it. It also comes with a little light, so if you're working on, you know, a board, you can tilt that up, have a light, and have your fan at the same time. So, pretty cool. Anything else on my desk that is vital? That's the bulk of equipment on my desk. I've got smaller things like little desk hoovers, so just turn them on, hoover up. Again, TikTok special. I've got something that now works, but I still don't think I'm going to end up using it. I think this is just destined to never be used by me. A desolder pump for clearing out holes on through-hole components when you've got the holes on here. There's a million different ways of doing it. Even though this works now, I've got the right size tip, the noise is just annoying and it doesn't fully clear the holes all the time. So you spend more time messing with this still than just using hot air or other things. The USB pens, yeah, the T80s and the pencils and T100s, GVDAs, I think the other ones are called. Yeah, they're all pretty good. But to be honest, that Yeehaw for a cheaper price is better in every way, and you can replace the tips. So unless you need the portability, then yeah, I'd recommend them. I also have, if you guys ever want them for free, I've got quite a few of them. I think they're called GVDA or GV something. I've got soldering iron tips and the irons. Yeah, GVDA soldering iron. So they're only like 20 quid on AliExpress now. But I tested them and I've got the tips and they work. So if you want a free iron, then you can just have them. Just ask me in the Elite Members channel, and any order you place on RetroSix, I can just post you out that. If you want a bench power as well, first come first serve, I've got probably about 10 bench power supplies you can have. They're like 200 odd pounds each. If you wanted to tip on RetroSix or just go to bespoke order and leave any money for them, that's, you know, obviously appreciated, but I don't expect anything. You can just go to retrosix.co.uk, go to send in service, scroll to the bottom and click bespoke order, enter £0 or anything, and then leave a note saying you like, please send free bench power supply. They are decent enough to use. They're not the highest quality, but these still cost between, I think, 150 and 250. I can't remember the price, but I used to sell all the equipment and I stopped, and I've got a garage full of spare equipment. So if you want a bench power, a a soldering iron I can chuck in for free. I've got... I don't think I've got much left. Everything else has been sold. I had picoscopes, oscilloscopes, but all them have gone. Bar, I think maybe one. But yeah, if you want bench power supply or iron, just ask. ESR meter, as in LSR meter, you mean, or LCR meter, or an actual ESR meter. We haven't actually covered that. I've probably got yeah, you can grab one of the bench power supplies. I also have. Do I have any spare? I was going to say I also have a hot air station spare, but I don't think I do because I'm not 100% convinced I'm going to keep this iron until I can this hot air station until I can figure out a way to mount the damn thing. It's just not convenient having hot air here, and then I've got a stupid bloody handle glued to my CRT behind me. So that's literally, there's my solution at the minute for holding this stupid iron in place. Going around there, hooking it in there, pulling it forward. So I can't do that like origami while I'm working, but it doesn't fit anywhere else on the desk because that's literally, that's the holder they give you. And this thing does not, that's weird looking at two of me, not one. This doesn't mount that way. You can't use the old stand because they've put the lip here, and this is wider than that, so you can't kind of rest it that way. It has to rest in something there like that, and they give you a shitty little stand that doesn't fit on the side of here on these screws, and even if it did, it would be like here and completely in the way. So I'm thinking of something up here, hooked on, made of wood, with a magnet glued in at the minute. But if that doesn't work, I'll be going back to the old hot air and making an adapter instead to adapt these nozzles. So I would have had a hot air spare as well, but at the minute I better keep the other one. But yeah, bench power, I can chuck you one of them in, just leave a note on any order. LCR meter I use a peak is somewhere. Where's it gone? It's normally in here. I don't know where I put it.
Oh, it's under the thermal camera.
So, I don't use the ESR meters, I use LCR meters, so this can test. Again, this is more if you're designing hardware or really want to test components. These are specific for testing capacitors and inductors, really. They're your two main things you'd use this for. Because you can't just test capacitors with multimeters accurately, and you definitely can't test inductors accurately. This thing puts current through, and at different frequencies, so it pulses current in and out at different frequencies to test how capacitors and inductors react on the time scale, which is how you need to test them. They're designed to operate differently through a frequency range. So for that I use a PeakTech 2170. You want good accuracy with this. That's where you really need accuracy to know. If you're going to test stuff and you're doing it properly, you need one of these basically. So that's what I use for that. I've got, obviously oscilloscopes is a given in one way. That's for advanced diagnostics, and I can see all my cables have actually fell down the side when I've been moving stuff around. Knocking my monitor off as well. Let me, I've been wiring something else back in earlier. There we go. They're all now free. Put that back on. There we go. Yeah, so an oscilloscope will cover dedicated lessons on. They are for if you want to probe digital signals, so things happening. Again, a Game Gear is a great example because it covers so much. But say we want to figure out what was going wrong with this circuit now, and we know it's booting up, and we're just not getting red light. So at that point, you have to diagnose this board. You have to really look at schematics, figure out what should happen, look at the specific things like what the ICs do, what the CPU's doing, and it's normally reading data from, say, the game cartridge. So it'll toggle address pins and data pins to try and read the game's data. So in order to see that happening, you need an oscilloscope, and that's where you then diagnose all these things. So I've got, if you're interested in that level of advanced diagnostics, then again, RetroSix.wiki, you might have guessed it. All free, and it does cost me money to run, by the way. So all this is completely hosted for free. I put all my info in here, everything I learn and figure out, I give it away for free, just so everybody can learn from it. Getting to red light boot was one of the first things I did on the wiki. Explained how the entire power circuit works on the Game Gear, so I had to start with that first to know how everything worked and turned on. Once I got past that, the next major one was getting to reading game cartridges. So this then goes over this pin connector here, tells you all the pins, and I just map these out one at a time. This is before we had anything like this. This was the first visual diagnostics of any board that I've ever seen, me overlaying pins, so when I'm probing like this I can look up and know what pin I'm probing. I went through the whole Game Gear and did every single pin on every single major chip. And then after that, see, so this one is this chip here, this ASIC, so we know now every single chip on the board. We could, say, overlay this on here, and then zoom in on here and have a nice side by side, and be able to say, like, for example, I've color coded them as well. So those pinky purple colors on the left, these are address 0 all the way down. The blues are data. So we know all these are address pins that we want to probe and expect addresses. And they should go to the address pins on this cartridge connector, which is further up here. So you can see, like, the address pins in the pink should be these ones. First they should connect to the ASIC over here, but if they all connect, the next thing you want to do is probe with an oscilloscope, and you look for, and I'll probably show it off on here, here's the oscilloscope, so you've seen the actual data happen, and this goes through what to expect, what the signal should look like, what a bad signal looks like, what a good signal that you might think is bad looks like, but it's actually fine. And basically this is how you diagnose, I guess, more advanced electronics. This will be. This is looking at how circuits work. So this is useless if you don't understand circuit schematics and diagrams and the operating of the circuit. But that's where I like to get involved with. You know, that's how I make products. I basically figure out how the system really works, and then once I know how it works, I can then figure out guides that tell you where to probe with oscilloscopes to figure out what's gone wrong, basically. All depends on how far you want to go with repairs, because oscilloscope probing is a time-consuming effort, and it's really for those that are either curious like me and want to learn, or you've just got general curiosity and you want to kind of you want to see this, basically. You want to, you know, learn it and fix your own for, say, sentimental values. You don't care about the cost, you want to get yours working. Yeah, thanks. I'm glad you like the wiki. It is appreciated when people let me know, because, like I say, I do give all my knowledge away, and we do have a lot of people that just steal what we do or clone what we do, and it's nice to know that there are people that genuinely just benefit from it and appreciate it, and not just use it and try to take credits for things. So we'll cover oscilloscopes as well. What else do I have? Other than mechanical tools, things like, I haven't used this in a long while, but there is use cases for hot glue guns. Very, very rarely use it now. What I use instead of hot glue is normally Q-bond or epoxy, if I'm doing kind of fixes or permanent adhesions. Another good one is UV resin cure. So normally women use this on nails and things, or on like smoothing out ABS prints. You can actually blob a little bit of this over, say, traces of wires and cure it with a UV light, and it keeps it in place so the wires don't move. Screwdrivers, another obvious thing. Electronic screwdriver, one of your best friends for working quick. And then your normal small screwdrivers with quick change tips. Nothing special here, these are again just AliExpress jobbies. One other thing that is actually useful is a little grinder. So again, you can either use a scalpel, so proper surgical scalpel, or you can use a grinder. I've got a pretty aggressive grind tip on this at the minute. I normally have a finer one, but that's used to say expose traces. So say you need to solder a wire onto this trace. You can either get a grinding pen, and I think these are now just called PCB grinders. Sounds aggressive, but it's actually quite gentle on the board. This removes the top trace, and that's removed the what's called the silk screen, the coating over the top that stops it being conductive. And now we can solder. I presume we can solder to it now. So with that exposed, you could tack a wire onto that trace you've exposed. So that's one way of doing it. Another way is if you've got a delicate trace, say you've got these traces, even though the grinding pens can do it, let's go over these two, say you can just rub away like that, and it's a lot less aggressive and a bit more controlled. Same principle then. You can just take your iron. Sometimes you need extra flux on the thin traces, but if you just rub up, you can see they're tinned perfectly fine. So they are, let's zoom in a little bit more so you can see. They're now tinned up, ready to take wire. So we can nice and easily attach wires to them. So yeah, scalpel or PCB grinder tool, they'll be classed as. They're useful. Anything else? Oh yeah, solder sucker. This is what I actually use for cleaning them holes. So instead of the desolder gun I showed you, we can use a hot air. This is how I clear holes out. Get a hot air gun. Take that one off. Put a nozzle on. And if I turn the hot air on, say we want to clear out holes. You'd normally do this if you're removing chips. So on this there isn't really through-hole chips to remove as such. There's like capacitors that are still surface mount. There's only really this crystal, say, as a through-hole, but it'd normally be for removing larger chips. So for 2 pins you wouldn't need hot air because you'd just warm it back and forward with an iron. But let's just pretend. Say this is loads of pins and you wanted to clear them holes. You can get this on here, warm up with hot air, and then use this desolder pump, which is basically a sucker like this, which is, these are the originals. They're called Engineer, and I can't remember the name because it's all worn off, but if you search for the word Engineer solder sucker, they're made in Japan. These are the best make. This is how I clear the holes. I just warm up the hole with hot air, and then this will probably fall out, to be honest, this crystal, because it's going to warm up that well, it's just going to fall out. And then once it's warm, you come in with the solder sucker, and then you pump like that, and you can see it's not quite ready. Give it another second or two, and then you clear the hole like so. So that's how you'd clear holes on a circuit. So that's a solder sucker. Ooh, Brad's put me a drink outside the door. Look at that, free drink. Right, so we've got the solder sucker. That doesn't fit back in my tub. I've got too many tools in there now. Put it in another one there. Anything else? Can anyone think of anything we have not covered, or you've maybe seen me use? Obviously, there's stuff like I'll keep that that crystal as well. There's stuff like the OSSC for getting desktop consoles into like on stream, for example. So I've got an open source scan converter down here plugged into HDMI, turn that hot air off now because that's deciding to just blow hot air. And if I turn that on, this is used to convert RGB, mainly RGB videos into things on screen. So that's the OSSC, and obviously there's nothing connected to the minute, but I could then show you guys consoles on screen. That's the one I'd recommend using for the RGB side. If you're using composite, so like that's a lot more common in retro consoles, I've got a scan converter down here that's running. You might have seen it on stream. I've got this down here, and what I've done is hacked it open, fit inside a clean comp universal. So now I have two connectors going in. So this now goes to the CRT, and this goes to the stream. So you guys can see on stream, and I can put it on this real, where are we? I can put it on this real CRT here and actually play a game with no lag, and you guys can see what I'm doing on stream. So there's that. Anything else? I think we've covered all the major stuff. Literally, I've got mountains of smaller tools. I've got things like USB testers, wire testers, like things like this. You know, like little USB testers. So if you wanted to know the current draw without a bench power supply, you can plug this into here, and then this into here. And then if you turn this on, if we then show you this, this is one way of measuring the power without having a bench power supply. If we turn on the system, you can see then it's pulling 50 milliamps if you trust this device. And you turn off, and it's saying it's pulling 23 and it's pulling nothing, so that's why you can't always trust these, they're not accurate enough. But that's, there you go, now it's telling us it's pulling 190, which is more expected, so that's as if it's booted normally. And then if we put a dead short over some pins, I guess, where can we dead short? Dead short the cap, you can see it just turns off and then turns back on, so it's not going to detect dead shorts as such because it's just going to power off completely. But useful for cheapness if you haven't got you know, too much money for all the equipment. These are good for testing power draw if you can plug into USB-C basically. Q-bond for gluing we've gone through. Wires, brushes. I don't think there's anything else major I'm forgetting tool wise. No, everything else is very specialist. Like when we do lens drops on consoles, we've got a little station for lens dropping and blowing air and stuff, but that is really, you know, specific. Same again, programming BIOSes and region-free BIOSes. We've got like a programmer XG ECU T56 if you want to program your own BIOSes and things. But yeah, I'd be here for like 7 hours if I went through all of the intricate programmers and tools I've got and specialist tools for every console. But I think that covers all of the major stuff. So the next one will be, if you want to follow the streams, I've set them up and scheduled them in. RetroSix, no, it's YouTube, isn't it? YouTube or TikTok, you can go to RetroSix. On YouTube, it's RetroSix. That's my echo. There's YouTube /RetroSix/live. Oh, when I'm live, you can't see it. When I'm not live, it'll show you the schedule. So, can I get to the schedule without, or while I'm live? Oh yeah, I can. Oh, you have to put @RetroSix. So YouTube @RetroSix. There we go. So if you put an @ in front of the username, or I guess browse manually, go to live, you can see the scheduled streams then for subs only. So we've got multimeter and bench tomorrow. What I'm going to be doing is an early morning one on a Tuesday. Is it Tuesday? No, it's Friday today, but normally early morning, nope, back to front. Late afternoon on a Tuesday at 4:30, and early morning on the Wednesdays. Yeah, that's the right way around. So Tuesday at 4:30 PM UK time, and then the next morning on a Wednesday at like this time on a Wednesday. I've just done today because I just have, but the sub only streams are going to be Tuesday and Wednesday for now at those times. And we have multimeter and bench, going through how to fully use every feature of the multimeter and the bench power supply on Tuesday. On Wednesday we're going to be killing stuff with the hot air, so that'll be like showing you how to use the hot air to maybe build a Game Gear ASIC, how to take resistors, capacitors off, how to desolder holes, everything basically I can think of. The next one, I've noticed as well the chat isn't coming up on stream, is it? I can see your guys' chat because I'm looking at it, but it's not popping up in the stream chat, is it? Not that it's a major issue, but it'd be nice so people could actually see the chat. I don't know why that's failed. Let me disable and re-enable. Let's see if that works. Yeah, thanks for sharing. Yeah, I don't mind at all. There we go. That should be working again now. I've only just noticed that. I've been reading the chat on the left and then just noticed it wasn't popping up on the stream, if you know what I mean. And then the one after that we've got booked in for the 2nd of December is trace repair. So if you were to damage these little traces on the board and you wanted to repair them, I'm going to go through that topic. So kind of a video dedicated each time to just very specific topics, so you can master very specific techniques. Again, obviously you're all members in here that are chatting, so if you have any suggestions for the videos that you want to see things on, use Discord. Go to discord.gg/RetroSix. The link's up there, just above the YouTube window. Link your YouTube or Twitch to Discord and you'll have an elite members chat. So if I pull up Discord so you can see. You'll see, you'll get a channel like this. So in RetroSix you'll have elite members, and in here we've got all the members, and you've now all got little gold tags and gold icons and that. So when you're in the normal RetroSix Discord, you've got a bit of bling that they know you're a sub and that you're supporting us because you've got gold names. So if you want to plan basically future streams in there and chat, that's where all the the conversations off stream will be. So I think that'll wrap it up for this morning. Again, if you have any more questions, or if you have any questions now before I jump off, just let me know. Otherwise, I will be back on. I'll probably be streaming over the weekend, depending on how much I've got to get done. I've got quite a lot of software to do, to be honest, but I'll see if I can stream over the weekend for just everybody. And then if not, the sub-only one will be Tuesday. I doubt I'll stream on a Monday. I'm always way too busy on a Monday. But yeah, I'll be back on tomorrow now, I'd say. Capture card, I use two different ones. So for these cameras, like this overhead one, super high quality. This is a Blackmagic camera going into it was originally going into Camlink 4Ks. They were working okay, but I ended up with like 3 of them on the USB rails. So it was loading down the USB of the computer. So this is now running through a Blackmagic Decklink, I think it's called, with 4 HDMIs in. So this one's running through it, the face cam's running through it. So I've got 3 of them. So all 3 main cameras now go through a single PCIe Blackmagic Decklink, but the OSSC capture and the retro scaler, because they are changing resolutions often, the Blackmagic does not like a resolution that changes. It wants to expect a feed and it's set and it doesn't change. So for the other ones, I actually use a U-Green capture card. I've got a tub full, and genuinely, like, I can see it from here. There's like, I can show you actually. Got a turny camera. I went through dozens of capture cards. So there, all that tub is full of every branded capture card I could find, like HDMI to USB-C. The one that works best is a U-Green capture card, and that doesn't mind the OSSC and stuff changing frequency all the time. So I actually use 2 different methods of capturing. Obviously, capturing static fixed cameras like this high quality, use the Blackmagic or Camlink 4Ks, but specifically if you're trying to capture retro gameplay, use a U-Green USB-C. I'll see if I can actually find where I brought it from, because I brought so many. Maybe that one's on Amazon. Let's have a look. I know a lot weren't. Let me just look at my purchase history a minute, and then at least you know the exact one that definitely works, and it's the one that you see on stream that never fails. Ooh, we might be... Oh no, that's a mini to HDMI. Adapter. Cables. We buy a lot of HDMI cables that are U-green. Power plugs, routers. There we go, got it. So this is the one you want. In chat. That one works perfect, and it is this one here. And I've tried all of them. Really, the key is the chip that's inside this. It's not that it's a U-green special thing. It's a specific encoder chip or decoder chip that works great. And you can see, super cheap as well. So you could probably use that as well to capture your cameras if you wanted. It's just that you'd end up with a load of USB rails on the PC. I found a couple that worked. Yeah, the Elgato HD60S I've got as well. I just couldn't find it at the time either, or I think it didn't do 60 frames, or I can't remember why I didn't use it. There was something about it I didn't use. Where am I from? I am from Stoke in the UK. And I want to say, let me double check, this is definitely the U-green. Yeah, so just so you know, I'm not lying to you. That's the U-green that's plugged in at the minute. That's the one that's literally capturing the HDMI for the OSSC, which I need to turn off. It's still on. Yep, that's back in. Again, things you probably shouldn't do live on a stream, unplugging stuff out the computer that's streaming. Right, that's that one out the way. Yeah, so I think that's it. Like I say, I'll be the schedules are now going to be booked in on YouTube and Twitch. So instead of me just showing up randomly, the subs have got a schedule where they know I'm going to turn up unless things go wrong. And the next one is planned for Tuesday at 4:30 PM. Oh, and there you go. That's probably because I've unplugged and replugged that USB. This camera flickered then for no reason. Or it could be the fact I've got that USB, that HDMI cable bent to all crap on that arm. Yeah, so I hope you guys enjoyed this one. If you want to watch it back, the VOD is on YouTube indefinitely. So if you go to RetroSix/live on YouTube, you should see a subs only playlist, and that's got all these played back and they don't get deleted, so you should have them to watch back whenever. Twitch, I think it only saves them for like a week or two, doesn't it? So they'll be on there as well, but only for a shorter period. And then I will catch you guys all either on the public stream over the weekend if I do one, and if not, on Tuesday afternoon for me. Thanks everybody for joining in. And yeah, I've clearly killed the chat on stream again as well, because it's popping up at the side but not there. Let me toggle it on and off. I don't know why that chat's decided to play up so much.